Our API is up and running. Time to start using it from Blazor. And for that, we'll use the HTTP client. When working with APIs, so from client applications like our Blazor application, there are a few important types we'll need to work with. The most important one, I reckon, is the HTTP client class. This we will use to send our HTTP calls. The second type, an interface by the way, that is important in this area is the HttpClient client factory. When working with the HTTP client, we'll in fact use the HTTP client service, and that needs to be injected in the dependency injection container in our Blazor application before we can use it. Blazor apps are, as I already mentioned, very similar to ASP.NET Core apps, and there too, everything evolves around dependency injection. It is built into the platform. As a small side note, let me explain you dependency injection so that you have the required understanding of what DI, or dependency injection for short, is about. Dependency injection will help us to create more loosely coupled code. Imagine that we have a class, here my class, and it needs a logger service. Instead of instantiating the logger service directly in the my class, which would create a hard dependency between the two, we bring in two things, an interface, iLogger service, and a dependency injection container, so the DI container. The container can be seen as the central point of information. We register there that when someone needs an iLogger service, they will get back a logger service. My class will then ask the container, can I please get an iLogger service? Based on the registrations that have happened, the container will return a concrete logger service instance. We've now decoupled things, and that makes things so much easier. Also, we don't need to create all required objects ourselves anymore. That is handled by the container too. The good news is, as said, that ASP.NET Core comes with the DI container bundled in the package, and Blazor apps will make use of that container too. So let's now see how we can work from code with the HTTP client. And I'll start with the basic approach where we use the HTTP client service directly. First, we must, in the program, register the HTTP client service with the services collection. The services collection is the collection of services registered in the dependency injection container part of Blazor. With the lines of code you see here on the slide, we are registering the service using the addScoped method. addScoped is a method that registers types with the dependency injection container with a scoped lifetime, meaning that an instance is created and kept around. We also pass in the base address where the API resides. If needed, this endpoint address can, for example, also be retrieved from a JSON settings file, but for simplicity's sake, I've hard-coded it here. Once you have registered the service, you can now use it directly in your component. In a component, we can access services inside of the collection of services registered in the dependency injection container using the inject attribute. We have in fact already seen this being used a few times. If I remember correctly, we also had used it to get an instance of the navigation manager. So this attribute will ensure that an instance of the HTTP client is retrieved from the collection of services if available. Registering it, like what I showed you on the previous slide, is what is needed to make this work. Note that the inject attribute can be used in components only, not in other classes where we may need an HTTP client instance. Now that the dependency injection system gave us access to an HTTP client instance, we can use it. A set of helper methods was added that makes interacting with the REST API over JSON very simple. Take a look at the snippet you see here on the slide. I'm using the getFromJSON_async method, which is a generic method. As a type parameter, we specify that we'll want the response to be returned as an array of employee instances. This will now result in an HTTP request being sent to the API/employee endpoint. Because the HTTP client was configured with its base address in the program class, the full URL will be used to make this HTTP request too. There are quite a few methods available on the HTTP client to help us with the communication with the REST backend. We have already seen the getFromJSON_async, which, as the name implies, is used to retrieve a JSON string from our API. There is also a post_as_JSON_async method. To this method, we pass the data we want to insert on our backend as a JSON string. Similarly, the put_as_JSON_async method is used to update an instance and to this method too, we will pass the object we want to update again as JSON. There is no real alternative for deleting an instance, although there is an extension method called deleteAsync, and that can be used to send a delete request to the API. This HttpClient API works fine directly in components. I will, however, use an approach based on the HttpClient factory, which in my humble opinion is the better approach to use. It gives us the ability to create and configure HttpClient instances in a central location. And we can also create named and typed HttpClient instances. We'll soon see what these are. Also, your code behind class needs to remain clean, and I suggest not writing too much code in there. I therefore suggest writing code that interacts with the REST API in a separate class. This can then easily be achieved using the HttpClient factory. Using the HttpClient factory in our application does require that we bring in an extra NuGet package, the Microsoft Extensions HTTP package. To use the HttpClient factory, we will need to go back to our program first and register the HttpClient factory with the services collection. That's what you see here on the slide. I now use the add_HttpClient method instead of add_scoped. And indeed, it's a bit confusing when it comes to the naming of the methods. The add_HttpClient extension method is used to bring in support for the HttpClient factory. We are using here the typed HttpClient approach. As I just mentioned, I don't like to put too much code in my components, and definitely not the code that will interact with my REST API. I therefore suggest writing code that interacts with the REST API in a separate class. I tend to call these classes service classes, since they have a single task typically. In this case, interacting with the API to get and send data. Here we are registering that the employee data service, which we'll see in the demo, will be registered with the services collection, and it will get an HttpClient instance from the HttpClient factory injected. Again, the configuration is done here. The endpoint and optionally other configuration to connect with the API is all added in here. Here you then see the employee data service implementation, implementing the interface employee data service, which we used to register the service in the services collection. This class will contain the actual logic to interact with the REST API, and therefore will need also the HttpClient. Now, the inject attribute that I just showed you, as mentioned, only works in a component class. This class is not a component, so we'll need to use a different way to get in the HttpClient. What I'm using here is constructor injection. As you can see, I'm using a constructor parameter of type HttpClient. This will be injected since we registered the HttpClient factory in the program class at the startup of our application.